We're going to do this question which has given us a graph. It tells us the graphs of y equals 2 to the power of x and y equals, in brackets, if we look over here, x take 2, x take 3 and x add 2 are shown on the axis. So the cubic function, which I'm tracing there, that will be the 3 bracketed term. The exponential 2 to the power of x goes up like that. Plot the graph of y equals x squared take x take 6 on that axis above. Now we're allowed a graphics calculator or something like that in this for this particular question at the level that I'm teaching. So I'm going to get up a graphics calculator. I'm going to get up my graphs. I'm going to go x, edit, clear all. So I'm not going to have those graphs in there, but I'm going to reproduce exactly that graph that I'm given. So the graph I'm given here, I'm going to get my view window to be from 20 to -10 on the y, -6 to 6 on the x, and I'm going to put those functions in there. So I'm going to reproduce exactly that onto my graphics calculator. So my first thing is I'm going to go my view window on this graphics calculator, which is actually the Casio ClassPad. My x from -6, I'll go -7 to 7, so just about the same. On my y's, I was going from -10, I think, up to 20, I think it was. Let's just move that over and have another look. -10 to 20 on the y max. Go OK. It's going to be my... Now I need to put in my two functions. Y equals 2 to the power of x, and I need to put in the function bracket x take 2 bracket times, got to put a times, if I just put bracket it won't work, x take 3 times x plus 2. Whoops. 2 bracket. Now I need to click both of these boxes and get it to graph it for me. And if I move that up so that we can have a look at it, it's graphed that exact same thing as we have on our question. We can see that that's virtually reproduced the same thing onto my graphics calculator. Hard to see. See if I can make this a little bit smaller. Can I make that smaller? No, I can't make that smaller, but that's you can see it's virtually the same as I flick from one to the other. Now I've got to put in my plot the graph of y equals x squared take x take 6 on the axes above. Okay, so what I'm going to do is I'm going to get up my graphics calculator and put that equation into my graphics calculator. So x squared, take away x, take away 6. I'm going to tick that, and that's going to be on that graph as well. So it's going to graph all 3 for me, 1, 2, and my quadratic. Okay. Now the reason I've done it on the graphics calculator is because in this particular question we're allowed it in the course that I'm doing. But if we had to do it, we're looking for what is our critical points. So on this graph that I've got to write on, from my graphics calculator, I'm going to determine my critical points. So I'm going to go analysis, gsolve, and I'm going to find this is a minimum turning point, so I'm going to go minimum on my quadratic is what the one I'm actually interested in. fact, I might do this yeah, on the quadratic. Whoops. So I'll do it again. In fact, I might get rid of these other two. That one and that one. I'm going to get rid of. I'm just going to have my quadratic up. So graph that again. Analysis, G-solve, minimum turning point. And it's going to tell me my minimum turning point is at 0.5 and negative 6.25. So I'm going to go up and go 0.5, negative 6.25. So 0.5 is there, and negative 6.25. I'm going to put a dot about there on my graph. Okay. Then I want to also get my other critical point. It's going to be my y-intercept. So where is my y-intercept? And I'm going to go analysis, G-solve, and y-intercept. My y-intercept is at 6. So I'm going to put a dot at 6 on my graph, which is going to be right about there. And then I'm going to get my x-intercepts, and that looks like negative 2 and 3. I can go analysis, G-solve, and the roots of the equation. Yep, negative 2 and positive 3. So negative 2, positive 3. I'm going to have a corresponding point here, and then I'm going to try I can't do it very well on this one because I'm not using my tablet for this, but I'm going to try and draw this as best I can as a quadratic. It's not going to be very good, it's not going to be very nice, but if I did this actually on my tablet it would have been a lot better. But there you go. I've got my quadratic function drawn on the graph. Now, but it would be better if you can make it look exactly like this one on my graphics calculator. Okay, with the three, your new one going like that. So, and we're going to use it now to also answer the questions. So, I'll show the turning point. Well, we showed the turning point on the graph. That was fairly straightforward. I did that. Find where the quadratic and the cubic intersect. Well, where the quadratic and the cubic intersect is there. And also there. So we could write them out as being the point negative 2, 0 and 3, 0. Okay, so that's going to be for C. And now we've got to find where 3 equals the exponential. So where 3 equals the exponential, now I can find that exactly on my graphics calculator. I can go from my exponential graph. I'm just going to move this so that I've just got the 2 to the power of x. I'm actually going to put in another function here. I'm going to put in 3, y equals 3. I'm going to draw that just to have a talk about it. So on the exponential, the little purpley pink line is our y equal to 3. Where they intersect, that's going to be our where our answer is going to be is with the x value of that. So I'm going to go analysis, and I can go G-solve and intersect of those two, and it's 1.584. So x equals 1.584 is the point where 2 to the power of x is going to be 1.584. Okay, so in solving this, if you've got a graphics calculator or something that will do that for you, then that's a really easy way of solving it. Hopefully that helped.